Basically, I just want to report the progress of the New South Wales government low carbon concrete specifications, which I have been working with DQ and EPA in the past 18 months or so. I thought I'd give a bit of my background that is relevant to this particular presentation. I was very fortunate in my early career to be working as a production engineer with white industry in Singapore. At the time, this Australian company was responsible for building 30,000 housing units for Singapore government, and I was put on the responsibility of doing all the mix design for both precast and in situ concrete for the project. We were producing about 700 cubic meter a day, Monday to Saturday, and Sunday if something go wrong as well. So it was a good learning curve for me before working for CSIRO, CCAA, and UTS at the moment. And this is where I want to start talking about, for most people who are not familiar with concrete with SCM. We work at CSIRO with Blue Circle Southern Cement back in the early 1990s for the introduction of concrete with high slag, 65 slag in that particular case. And at the time, it's mainly to do with improving the durability of the concrete. So that type of concrete was used for the Sydney Power runway, the picture on the right, and the Wandoo platform in Western Australia, roughly in the mid-1990s. High volume fly ash concrete, again, CSIRO was working with the Electricity Commission of New South Wales, who at the time was responsible for all the power stations in New South Wales, and therefore want to see whether we can make better use of fly ash. So the development again was conducted at CSIRO with trial mix at Mount Piper Power Station, and the first commercial use was for the foundation of Crown Casino in Melbourne, mainly because of the high sulfate resistance of the concrete. So again, concrete for specific aggressive environment. Silica foam, on the other hand, at the time, again, in the early 1990s, we were working with CSR ready-mix concrete. Okay, that's the CSR now the Holcim, is it?
Oh, well, got for a bit. I think CSR went into like, or is it ready mix or Rinker and stuff, and then I think maybe split off as well with some of the different materials as well.
Yes. You're correct, Luke, because we did first silica fume projects in Melbourne when it was ready mix.
That's right. They first developed it for use of high strength concrete, of course, and some of the major high-rise building in the late 1980s to early 1990s were silica foam concrete. But in the case that we work with CSR ready mix, it eventually was used for the wall for the Sydney Power runway, the one on the right, the picture on the right. So this is just to highlight the fact that concrete with SCM is not new. We've been using it since the 1990s, mainly for very aggressive environment. So what is low carbon concrete? To me, is like any other concrete with good workability, strength and volume stability, and durability with respect to the design line. The only difference is that we are trying to produce concrete that meet these three requirements at the minimum possible embodied carbon. So that's my definition of low carbon concrete. And the reason is quite simple. The embodied carbon of the different materials, you can see that fly ash and slag, for instance, a fraction of the embodied carbon per kilogram or per ton compared to general purpose cement. So if we can make best use of blended cement, I guess, then we can produce concrete with lowest embodied carbon. And this basically, I think it's true. Possibly, I briefed Metla event some couple of years ago, and New South Wales government basically then approached us that can we work with them to start, rather than specify structural performance, durability performance, can we start working with them to specify environmental performance as well? And in this case, we are looking at specifying it in terms of the upfront embodied carbon. So basically, the two New South Wales government departments, that is DQ and EPA, basically come to work with UTS and sponsored partly by SmartCrete CRC in this work. So this is what we have done. Very, very specific type of concrete that we recommend. The first one is ASTM, so I beg your pardon, Australian Standard 1379, normal class concrete. And with certain slum, and for normal class concrete, the 1379 also specifies 7-day strength as well. So apart from that, we are also looking at recommendation for special class concrete, meeting construction requirement according to 3600, meeting construction requirement according to 5100.5 for 100-year design life, and also some information about early strength for precaster as well. So this is what basically we have done so far. This table shows basically the scale of the work that we are doing. You can see that for normal class concrete, for different grade, we work from grade 20 to grade 50. The target strength, assuming a standard deviation in production of around 3.5 MPa, which I think is achievable by most concrete suppliers. The required 7-day strength, and then with a range of different SCM and general purpose cement, we then work out those concrete and the embodied carbon required. This is just to give visually of what can be saved, I guess. If you look at the graph on the right-hand side, basically we looking at the embodied carbon of different grade of concrete with different type of SCM in comparison to the embodied carbon of the concrete of same grade, simply we're using GP cement. Of course, this day we probably don't have much of that type of concrete anymore. But you can see that with fly ash and slag, you can reduce the embodied carbon by around 30%. And if you are game enough to go for triple blend, you can reduce it by roughly 50%. So these are significant embodied carbon saving that we can basically promote the use of low carbon concrete. The graph on the left basically show the same information, but in this case, in the value of embodied carbon itself for different grade of concrete. We also show the position of the embodied carbon in relation to Cement and Concrete Australia low carbon band, I guess, from the band AA at the bottom up to band F. These were adopted from the global ACC, Cement Concrete Association, low carbon bannings. You can see that if you use the sort of low carbon concrete, the binary system, the fly ash, the slag, for most grade, we are in the lower boundary of band D. Whereas if any batch plant have the capacity to use triple blend, you can bring it down to band C. So a great improvement. So the recommendation that we have is the one shown on the red box up top. Very specifically, what target strength, what 7-day strength, what type of binder, what embodied carbon you have. Now, when we present a lot of this work to people, the very first question that people ask is that, are the industries can supply this type of low carbon concrete? And basically, Metla have provided the answer for us. And I obviously want to refer to the version 2 of the guide to low carbon concrete by Metla that you are responsible for. And in particular, this particular version basically gives state by state what the current industry are able to supply in terms of the embodied carbon or global warming potential for different grades of concrete. It's probably worth noting that if you look at those statistical box and basically the level, the lower part of the box, which is the 25 percentile of what the producer can supply, also coincide with the lower part of band D. Okay, that's quite important. So if we then look at the Metla data of 25 percentile, and this is data specifically for New South Wales only, because the work we are doing is for New South Wales government. You can see that it's basically the 25 percentile value lie very similar to the binary system that we recommended, either with fly ash or slag. And the most important thing is that for plant which can handle triple blend, you can actually reduce it much further as well. So I guess that's the incentive for user out there to even specify triple blend mixes. Is there any question at this point in time?
Probably as a comment for it. I mean, that's amazing to kind of see like the application and the use of, I guess, of the Metla data and also kind of thinking about how that like can be replicated across Australia by the different like state agencies. Now you got that state data, you can kind of start looking at, well, could we set a target or what would it look like? How do we perform? So really great to see that and pleasing. And also I think like the alignment of the GCCA banding obviously was what's available in the market in Australia is also quite matches quite well obviously as well. So probably just one of the initial thoughts, I guess this is like assuming like all, well, I guess your modeling just assumes like a generic emission factor, and then obviously like the EPD data, I guess that's like market specific emission factors as well. So I guess that also kind of shows that, you know, maybe even more is possible, I guess, depending on like what your inputs are and your mix designs and your efficiencies and all that. Yeah.
Certainly. I think the mix that we use are not optimized in any way at all. Producer obviously can optimize their mix much better than us. We have, in particular, as far as concrete gradings are concerned, we did not have the material that enable us to have a much better concrete grading, which affect the efficiency of the binder for any concrete production. So we are not, I must say here, we are not trying to compete with the industry. We are merely to set, in a way, a benchmark of what can be achieved to encourage the industry to even doing better than this value. But for organizations like New South Wales Government Agency and so forth, I guess they can at least rely on this as that they are assured that the industry can supply, basically. And that's the reason why we gave solution for fly ash, slag, and the tryptophan, depending on the supply chain that are available in different part of New South Wales in this case, and also in depending on the capacity of the plant to handle, I guess, more than one type of SCM, for instance. So the solution hopefully are generic enough to accommodate.
And probably just adding to that, like thinking about it as well, like, I mean, hopefully at some stage there's like the confidence like to move from a prescriptive based approach to like, hey, use like you know, binary or tertiary kind of blends, like, you know, at least as a minimum to like a performance outcome, I guess allow the industry to kind of, you know, find the most cost effective or efficient method to kind of doing that rather than, oh, hey, it has to be this, because I guess also we've seen from some of the other presentations, like say a fly ash was an activator, might be able to kind of go lower again as well. And, you know, comparable maybe to a triple blend. Obviously there's different people have different materials, there's like different embodied carbon as well. So I think hopefully at some stage they can kind of have the confidence to just move over to embodied carbon, and, you know, which allows the industry to kind of work within those, the specifications.
Yes, this is a very important point. In fact, the mix that we recommend, or the embodied carbon that we recommend for different mixes here, are those that would meet either the 3600 or 5100.5 for the durability. 3600, of course, do not specify the type of binder. And the main specifications are strength and cover for different exposure conditions. Okay, 5100 on the other hand do have prescriptive requirement in terms of the limits of different SCM in it. So those were taken into account in all this work. And this is where I'll go further a little bit.
Vute, sorry, we have one more question as well. If you want to kind of, we'll ask it now. It's from Mindy. Thanks for the presentation. The question I have is how the project characteristics are considered beyond the mix level, how agencies are aware of the differences. If you got any thoughts on that. So how is project characteristics considered beyond the mix level, and how are they aware of the differences? Mandy, do you have anything you want to add to that at all, or Vute, your thoughts?
I don't follow the question. Perhaps it can be clarified.
Yep, thank you so much. I'm sorry, I'm on the phone. The issue like we have is like if someone take this great number and put in a specification when we work on a big project or government project, and we don't know that they don't know the differences. These are at the mixed level, and we don't necessarily use that 40 MPa all across your project. The 40 MPa for a project could be wide range type of 40 MPa. And how agencies are aware of those differences? Are they going to be 40 MPa for a slab, 40 MPa for column, or 40 MPa for foundation? But total different type of 40 MPAs.
Well, firstly, this is fairly generic. In fact, we do make exception. For instance, if you want to use concrete for post-tension slab, for instance, definitely we would not recommend this, because post-tension require, apart from the grade requirement, it requires specific early strength. And that with post-tension in particular, I think the problem is, or the challenge is that while certain concrete may meet the requirement in certain area, we know, for instance, work that was done in Sydney, a particular type of concrete would meet the requirement. But if you use the same concrete in Canberra during winter, it will fail. So those are very special type of concrete, which is not included in this. Okay.
Oh yeah, no. What I'm saying is, it would be great to pass a message to the agencies so they'd be aware of those differences. So,
yeah. In
yeah,
fact, I stated at the beginning that I didn't spend time talking about it. I'll come back to that. Okay.
Could I just make a point? It's me. It's Tom Kovacs, Vute.
Yes, Tom.
I hope you don't mind me butting in there. But just to reiterate exactly what was just said, one of the biggest problems we have with particularly reports that come out very similar to this is that people take this report and they will put a blanket, as per the tunnels were in Sydney earlier, a couple of years ago, 286 maximum for every 40 MPa. And that was a huge issue for the industry because that's what they put in the specification for that project, right?
Is that embodied carbon, Tom, or cementitious?
No, embodied carbon, right? So it was a huge struggle to do that because we had to pump concrete 1.2 kilometres into a tunnel, and we had to meet all these environmental constraints on top of 286 kilos, which is what the contractor put on us in terms from their green consultants on the project. So we've got to be very careful, and we keep harping on about this, and within this group and the CCA about application. And it's not just good to be honest, but to put something in the preface talking about it should be used for all grades. No one will read that. They'll just see that number in your table, and they'll copy and paste that table and they'll put it into a spec, and you'll have a poor supplier saying, well, this has got precast and it's got post-tension work, we can't meet this. And they say, well, we'll go somewhere else. And that's typically what happens in the real world. The other comment I'd like to make is that I'm not quite sure why you've used 40% fly ash and such high triple blends, because most typically, when we use over 30, even up to 35% fly ash, we have a huge issue with performance in terms of strength performance. I'm not sure why you've gone down the road of 40% fly ash, because for mine, we very rarely go that high. And if we do, typically it's for, only very low grades and for foundation type work. So you don't go over that 30, maybe 35 occasionally. But why you've gone for the 40, I question that. And also with the triple blend, why that's so high. I mean, most triple blends are like 25-30, 25-25. To be going that high with only 30% of GP cement is extremely low. And performance-wise, it's an issue because the quality of some of the fly ashes we have can't go that high.
Yeah, I think all those comments are very relevant. I think it's all to do with the education as well. I mean, and I take note of that in trying to be more specific about possible application, which I actually noted down, but I didn't talk about it. I'll come back to that in a minute.
Once you put in this table,
the percentage-wise, though, is the work that we develop. But when we specify, the recommended specification is what you see right now. We talk about fly ash, and people can optimize it differently. Whether it's 30%, 40%, they can optimize. I guess depending, as you say, the source of fly ash and slag for that matter. Every time we have a different lot of slag, we get different performance, slightly different performance. So that, I guess, is well understood among, I guess, people with experience. But I take note of the fact that, yes, perhaps we need to be more specific about what we recommend for. I mean, you presented a talk about special low carbon concrete for post-tension slab, for instance. That's the sort of thing and I'm so glad that you share that type of information, where special type of low carbon concrete, which probably have pretty low carbon, like similar to what we recommend here, for particular application, which is quite challenging.
And the other thing you mentioned was constructability in one of your slides there. Now, for us, constructability, and for a lot of constructors out there, constructability is 12 MPa overnight, so we can strip or we can do whatever.
Let me go through the next one. Okay, this is normal class 7-day strength specification, but we also have further recommendation. This is just the normal class. Okay. Now for special class concrete, the embodied carbon that we recommend are much higher. And that's because they are particular, this case is 5100.5. There are particular minimum strength requirement, 3-day, 7-day, 14 days between different grade of concrete. So that has been taken into account, the early strength requirement, depending on the grade of concrete, and these are for special class. So what I've shared with you before was just for normal class.
Okay, yeah, thanks for that clarification. Yeah, I was thinking that, yeah, as well. I mean, probably really good segue to MECLA version 3 as well, I think, and like the demand for it. I think this is great conversations as well. And I guess, yeah, like, yeah, I guess it shows like how important application and embodied carbon reduction possible is, and also per state, I guess, as well, obviously, depending on the materials that you have.
And I think you may have mentioned about the prescriptive requirement in 5100.5. Prescriptive requirement in 5100.5 was taken into account. For instance, the triple blend mix that we recommend here, the percentage of fly ash and slag are within the limit recommended in 5100.5. So those requirements are taken into account in recommending this type of embodied carbon for a fairly specialized concrete. So special class, normal class, they are different, okay? And in fact, my comparison with your data, with METLA data, I assume that METLA data are talking about normal class. I could be wrong there.
The MECLA data is all types of concrete at this stage for the state. And then obviously version 3 will kind of then drill into state application is the aim.
Right. Although
Andrew,
volume 2 already have information state by state already.
Version 2, I guess version 1 was all of Australia, all types of concrete. Versions 2 is all types of concrete in state, and version 3 will hopefully be broken down by application and by state if we've got enough information per state as well with the data through coming to up. Andrew, do you want to ask you a question now? I'm assuming it's on this point as well.
Sorry, it's not a question, just a comment in response to the issue that Tom raised about these tables like this sort of being copy and pasted as a requirement into, and then passed on to the supply chain. We've definitely seen that, but I do think there's starting to be a bit more maturity coming to market now, where the table might be copy and pasted, but how it's applied is not so black and white. So for your example there of all 40 MPa concrete has to be 285 or whatever it was. What we're seeing now is that the average of all 40 MPa concrete might need to be 285, for example, and that allows those overs and unders for situations where it might be really difficult in a certain application.
Yeah, and Andrew, in your briefing at METLA, I think you demonstrate a very good example of people who can make best use of information. I think especially when you talk about the precast, for instance, I was really impressed that for precast, you obviously have to look very, very specially about how you kill your precast element and the strength required and so forth. And therefore, you can't use a generic embodied carbon table like this. And that probably come back to the very first question. A lot of education need to occur. And I think METLA already are doing a lot of that already. And perhaps a lot more need to be done. Can I just continue just a little bit more on durability requirement, actually, which is quite important. We also provide a bit of information for normal class. For precaster, we can't supply information that is useful for everyone because everyone kill their concrete differently. So basically, we kill our concrete with this specific type of curing temperature, and then report the one-day strength as well as the embodied carbon of the concrete. This is really strictly for information only because precaster use different curing regime all the time. Okay, so durability of low carbon concrete for our project, this is of vital importance. And I think we already have the experience knowing that concrete with SCM are very good for sulfate, for chloride, but not so good for carbonation. And it's also very good for mitigation of alkali silica reactivity. For those in the business, of course, you can look at HB79 for the use of SCM to mitigate alkali silica reactivity. Carbonation is the one that we have concentrated on. And we've done the work at UTS for accelerated exposure, outdoor exposure, indoor exposure, and so forth. We finally recommend to BD2 in the current revision of 3600 to change, to increase the cover for exposure A2. In exposure A1, basically we reclassify the exposure to strictly talking about indoor exposure only. And for indoor exposure, there is no availability of readily availability of water. And therefore we are not too worried about the long initiation period, I guess. And in fact, that high carbonation indoor is actually advantaged for our industry in terms of recarbonation, in other words, capturing the CO2 back into the concrete. Externally for A2 though, corrosion will be a problem, and therefore that's why we have recommended the increase of concrete cover in the red color there for 5 millimeter, most of it, except for grade 20. In fact, we recommend a reduction in the cover. This, by the way, the revised 3600 is out for public comment at the moment. So please, for those who are in the business, please review the recommendation, not just for section 4 on durability, but all the other section as well of 3600. We will recommend increased cover for exposure A for 5100.5 as well, but that will take longer time for the committee to look at. And that's my conclusion, basically, that low carbon concrete can certainly be specified for the environmental requirement for various grades. And Metla basically shown that the industry is in a position to supply low carbon concrete, and the durability aspect have been looked at comprehensively. Thank you.